Caesar cipher. A Caesar cipher is one of the simplest and most widely known encryption techniques used in cryptography. It is a type of substitution cipher in which each letter in the plain text is placed by a letter some fixed number of positions down the alphabet. For example, with a left shift of 3, D would be replaced by A, E would become B, and so on. The method is named after Julius Caesar, who used it in his private correspondence. The encryption step performed by a Caesar cipher is often incorporated as part of a more complex scheme, such as the That doesn't fucking help me at all! The cipher. It still has modern application in the ROT-130 system. As with all single alphabet substitution ciphers, the Caesar cipher is easily broken and in modern practice offers essentially no communication security. Example. The transformation here can be represented by aligning two alphabets. The cipher is the plain alphabet rotated slightly left or right by some number of positions. For instance, here is it. Cipher, Caesar cipher, using a left rotation of 3 places, equivalent to a right shift of 23. The shift parameter is used as the key. When encrypting, a person looks up each letter of the message in the plain line and writes down the corresponding letter in the cipher line. The quick brown fox jumps over the lazy Deciphering is done in reverse with a left shift of 3. Ugh. The encryption can also be represented using modular arithmetic by transforming the letters into numbers. According to the scheme, A 0, B 1. Yeah, that makes sense. I meant that sincerely. It does make sense to me. Encryption. En x equals mod 26 modulo operations replacement remains the same as the message. So the cipher is classified as a type of monoalphabetic substitution as opposed to polyalphabetic substitution. History and usage. The Caesar cipher is named after Julius Caesar, who, according to Suetonius, used it with a shift of 3. A becoming D, D becoming A, to protect messages of military significance. While Caesar's was the first recorded use of this scheme, other substitution ciphers are known to have been used earlier. If he had anything confidential to say, he wrote it in cipher. That is, by associating that opera loaded, not a word could be made out of it. His nephew, Augustus, also used the cipher, but with a right shift of 1, and it did not wrap around to the beginning of the alphabet. Evidence exists that Julius Caesar also used more complicated systems, and one writer, Aulus Gellius, refers to a now lost treatise on the ciphers. There is even a rather ingeniously written treatise by grammarian Probus for concerning the secret meaning of letters and the composition of Caesar's epistles. It is unknown how effective the Caesar cipher was at the time. There's no record of any time that any of the techniques for the solution of the cipher, simple substitution ciphers. The earliest surviving records date to the 9th century works of Al-Kindi in the Arab world with the discovery of frequency analysis. A piece of text encrypted in a Hebrew version of the Caesar cipher, not Apache, sometimes on the back of Jewish mezuzah scrolls, when each letter is replaced by the letter before it in the Hebrew alphabet. Text translates as Yit some YHWH. Our God, YHWH. A quotation from the main part of the scroll. In the 19th century, the personal advertisement section of newspapers would sometimes be used to exchange messages encrypted using simple cipher schemes. David Kahn describes instances of lovers engaging in secret communications and ciphered using Caesar cipher in The Times. Even as late as 1915, the Caesar cipher was in use. The Russian army employed it as a replacement for more complicated ciphers, which had been proved to be too difficult for their troops to master. German and Austrian cryptanalysts had a little difficulty decrypting their messages. Caesar ciphers can be found today in children's toys such as secret decoder rings. A Caesar shift of 13 is also performed in the ROT13 algorithm, a simple method of obfuscating text widely found on Usenet and used to obscure text such as joke punchlines and story spoilers, but not seriously used as a method of encryption. The VIGENERE cipher uses a caeser cipher with a different shift at each position of the text. The value of the shift is defined using a repeating keyword. If the keyword is as long as the message is chosen at random, it never becomes known to anyone else, and is never reused. This is the one-time pad cipher. Proven unbreakable. Complete victory used by the Confederacy during the American Civil War introduced a cyclic pattern that may be detected with a statistically advanced version of frequency analysis. In April 2006, fugitive mafia boss Bernardo Provenzano was captured in Sicily, partly because some of his messages, just clumsily written in a variation of the Caesar cipher, were broken. Provenzano's cipher used numbers so that A would be written as 4, B as 5, and so on. In 2011, Rajab Karim was convicted in the United Kingdom of terrorism offenses after using the Caesar cipher to communicate with Bangladeshi Islamic activists discussing plots to blow up British Airways planes or disrupt their IT networks. Although the parties had access to far better encryption techniques, Karim himself used PGP for data storage on computer disks. They chose to use their own scheme implemented in Microsoft Excel, rejecting a more sophisticated code program called Mujahideen Secrets because Kafir's or non-believers know about it, so it must be less secure. Because absolutely nobody knows about the Caesar cipher. The Caesar cipher can be easily broken even in a ciphertext-only scenario, since there are only a limited number of possible shifts, 25 in English. An attacker can mount a brute force attack by deciphering the message or part of it using each possible shift. The correct description will be the one that makes sense as English text. An example shown on the right for ciphertext EXXEGOEXSRGI. The candidate plaintext for shift for attack at once is the only one which makes sense as English text. This technique is sometimes known as completing the main component. Another approach is to match up the frequency distribution of the numbers by graphing the frequencies of letters in the ciphertext and by knowing the expected distribution of those letters in the original language of the plaintext. A human can easily spot the value of the shift by looking at the particular features of the graph. This is known as frequency analysis. For example, in the English language, the plaintext frequencies of the letter E, T, and Q, Z are particularly distinctive. Computers can automate this process by assessing the similarity between observed frequency distribution and expected distribution. This can be achieved, for instance, through the utilization of the chi-squared statistic, or by minimizing the sum of squared errors between observed and known language distribution. The unicity distance for a Caesar cipher is about 2. Meaning that on average at least 2 characters of ciphertext are required to determine the key. In rare cases, more text may be needed. For example, the words river and arena can be converted to each other with a Caesar shift, which means they produce the same cipheric text with different shifts. However, in practice, the key can almost certainly be found with at least 6 characters of ciphertext. The Caesar cipher, encrypting a text multiple times, provides no additional security, because 2 encryptions of, say, shift A and shift B will be equivalent to a single encryption with shift A and B. In mathematical terms, the set of encryption operations under each possible key forms a group under composition. I knew more about that than it probably sounded like. I'm really hungry. I hope my pizza gets here soon.